The use of a quantifier turns an open sentence into a statement. Our ultimate goal is to prove the statement true or false. But how? A good general strategy, which we'll discuss more, to prove a conditional, begin by assuming the antecedent. So as long as we have a conditional, we have a starting point. But what if we don't have a conditional? Consider a statement like every quasit is a glurby. If Q is a set of quasits and G is a set of glurbies, this statement can be written as. Now, remember that informally, a conditional can be interpreted as follows. If you have something, then you have something else. And so if we take a look at our statement, the question is, what do we have? Now, the statement is for all quasits, so that suggests we can rephrase it as, if you have a quasit, then it is a glurby. And this suggests the following strategy. If a statement begins with a universal quantifier, that should be the antecedent of a conditional, and the rest of the statement will be the consequent. So let's restate as a conditional. For all quasits, there is a glurby that is fromulous. So letting Q be the set of quasits, G the set of glurbies, and F the set of fromulous things, we can rewrite our statement in symbolic form as. Now our leading universal quantifier gives us the antecedent, X is quasit, and the remainder becomes our consequent. There is a glurby that is fromulous. And so we can rewrite this as the conditional, if X is quasit, then there is a glurby that is fromulous. Or let's take another example. For all quasits and for all glurbies, there is a rockroy that is fromulous. So letting Q be the set of quasits, G the set of glurbies, R the set of rockroys, and F the set of fromulous things, we can write our statement as. The leading universal quantifier becomes the antecedent. X is quasit. And the rest is the consequent. But notice that the remainder starts with another universal quantifier. So we could write this as the antecedent of another conditional. So this becomes the conditional, if X is quasit, then if Y is glurby, there is a rockroy that is fromulous. So remember, a useful strategy is to solve it again, and in this case, remember that consecutive identical quantifiers can be switched. And that means we can write our sentence as. And now our leading universal quantifier is for anything that's a glurby. And so this statement becomes the conditional. If Y is glurby, then if X is quasit, there's a rockroy that is fromulous. Or consider a statement using even more bizarre terminology. All composite numbers have a prime factor. So let C be the set of composite numbers and P be the set of prime numbers. Since the statement claims something true for all composite numbers, there's a universal quantifier involving composite numbers X. So our statement begins for any composite number, and since it claims the existence of a prime factor, there is an existential quantifier involving some prime number P. So there is some prime number, and we'll write that prime number P divides X, and we'll write it this way. Rewriting this as a conditional, the universal X is composite is our antecedent, and the rest of the statement is our consequent. So our conditional would be, if X is composite, then there is some prime P that divides X.